Awesome. Hey everyone, my name is Alex Carruth, and today I'm going to be talking about experimentation with adding heat to virtual reality using tactile feedback. So before I get started, a little bit more about myself. I'm currently a computer and electrical engineering student at NC State. I'm also a technical intern at BioMojo, and without BioMojo, today's presentation would not be possible. And I'm also a member of the NCSU Mixed Reality Lab, which is the lab that I did most of the research that I'm talking about today through. So I'm going to talk a little bit about what I did at BioMojo, just to start off talking about them. So BioMojo, in terms of game development, the interns have been working on this summer natural language processing, which is applicable to game development in terms of speech to text and adding in voice as it becomes increasingly more important, especially in the world of VR. And we also worked a lot with experimentation with the HoloLens and seeing the different applications of softwares with that. So a little bit about what I'm going to be talking about today. So we'll start out talking about software development kits. I'll explain that a little bit more, but essentially it's going to be getting the hardware that has that connects the heat into Unity, and that's sort of the background of that. And then we'll talk about actually adding heat into virtual reality and what that looks like. So starting out, so essentially what adding heat to VR does is it increases the immersion. So what is current tactile feedback technology? There's phones. So if you ever have your phone vibrate for a text or something like that, that's an example. Your game controllers, like an Xbox controller vibrating while you're playing a game. There's current gloves in VR, like the Manus glove, which has vibration feedback. And there's also vests that have vibration feedback. And then eventually we're working our way towards, in the future, full body suits with haptics and tactile feedback, such as the one seen in Ready Player One. All right, so starting off, to know the utility of an SDK, you have to know kind of what it's useful for. So an SDK is a software development kit, like I said, and it is essential for adding in tools as a package into your software. So if you want to think of examples of SDKs, you can think Apple for making apps, you can think Java for developing apps, and you can think like Google Cloud and working with cloud applications. So essentially, it makes it easier to program by adding in functions that sort of abstract a lot of the concepts. And so I'll talk a little bit more about specifically what the software development kit we made is. Essentially what we're doing is we're taking hardware, interfacing with it with a microcontroller, which is like a mini computer. And the microcontroller we used is called the, or it's under Arduino. We actually use multiple microcontrollers, which I'll talk about. But yeah, it's essentially taking a computer, mini computer that controls hardware and interfacing it with Unity, which is a game development engine. And so that's useful for, well, let's take the example of Ready Player One again. So as you can see in this picture, he's wearing gloves. That's an external hardware peripheral. He's on a treadmill that also had to be connected up to his headset. So what we want to do with developing the SDK is make it easier to get those external hardware peripherals into VR. And that makes for a happy coder. So you see that guy, he probably has an SDK, he's smiling. So yeah. All right, and so moving from the SDK, how does that apply to heat? So like I said, adding in heat would be an example of a hardware peripheral. And so where that comes into play in VR, and why we thought it'd be a useful extension, is there you already see a bunch of examples of heat in VR. So you have cooking in the kitchen. Hopefully your kitchen isn't exploding like it is over there, but that's one example of heat. You have your gun overheating in Halo, which we actually made a demo for. I'll be showing that a little bit later. And then you have just various fires and torches that you'll see in VR. So heat definitely can play a role in immersion. So a little bit more going into the technical side of things of the software development kit and what we do with that. And it allows us to code the future. Previous work done in this area. Getting Arduino to interface with Unity. There's Arditi. That's a free plugin. It's the most popular free plugin. The problem with, I guess, all of these plugins is they're a little bit too deep into the world of coding. And one of our goals is to make it so anybody can develop with our software development kit, even a beginner to Unity. So the problem with these ones is they're using serial libraries, and a lot of people, serial communication is hard to understand if you haven't worked much with that kind of stuff before. And so it's really more focused on the serial side of things. And what we're doing is abstracting functions from those serial things. There's also Arduino, which, like I said, it has the same problem, but it adds some more advanced functions. So I figure it's worth talking about, and that one's paid. And then there's also the Arduino Bluetooth plugin, which is pretty popular, and it has Bluetooth low energy, which we were not able to get, but we got Bluetooth working, and I'll discuss that in a little bit. So that's kind of like the predecessors, some examples of what has been done before. And so here's what we did. So how do we think about developing this? We started out, we were like, well, let's just get a basic serial connection working, right? That's the foundation of anything. Let's make sure we can communicate to our microcontroller or our mini computer brain. We just connected that using the serial ports library of Unity. So it's already built into Unity. And overall, that was pretty easy, but it was good to know that we could connect to the Arduino. And then from there, we started to think about, well, what can we prove the use case of this for? So we got this package from a company called Lumia. It was a development kit, and it had heating pads and LEDs. And so, heating pads, obviously, we expanded upon that a lot more. But starting out, LEDs are a lot easier to work with, especially circuitry-wise. So we were like, okay, let's use LEDs. And so from there, we decide, well, what do we use them for? And we decided that they could be used to backlight your VR headsets. So if you're looking at maybe an enemy and need to know where they're at, an LED could turn on one side indicating where the enemy is, and it wouldn't block your screen at all. So that's a potential use case and a basic way to implement it and show its practicality. And I have a demo of that I'll show after the slide, but a couple more things. We also looked at the namespace hierarchy. So we created a map of that, and I'll show that in just a second too. But essentially what a namespace hierarchy is how are we gonna set up our SDK to develop for the devices to make it make sense. And it'll be easier to explain that once I go to that slide. Like I was saying, we looked at more SDK use cases, which is when we started expanding to heat. And we also looked at Bluetooth functionality, so easily getting Bluetooth into VR. All right, so here's the SDK map. So it starts out by just the namespace, MXR. So like I said earlier, I was working with a mixed reality lab. So MXR is encompassing all of the work that we've done with that lab. And then we go down to class, so the basic device class. And here in the class, we'll also add on later specific heat and light functions. And I'll talk a little bit more about what we think those will be in future work. But yeah. Under that, we have the actual functions encased by the device. So connect to Arduino allows you to either connect via the port or connect via the Bluetooth connection. Device on and device off, obviously simple, LED on, LED off. And then device power is just, you can control the amount of power going to your circuit. All right, so I'm gonna show you guys real quick a video of the LEDs working and how a quick demo with the enemy. So, and I'll explain a little bit more in the actual demo video. So let me just set that up. Hey everyone, so all right, I'll play that for you guys now. I'm going to be doing a demo of the basic SDK functions that we wanted when we first started out. So on the screen here, you'll see this ball, and then on the Oculus Quest headset, you'll see two LEDs mounted. So when I'm looking to the right, this left LED should light up, telling me that the ball is to the left. And then when I'm looking to the left, this right LED should be lighting up, telling me the ball is to the right. And normally these LEDs would be inside the headset. But I'm going to go ahead and demo this for you. All right, so we'll start out turning on the ball real quick. And then if I look to the left, this LED should be lighting up. And then if I look to the right, this LED should be lighting up. Awesome. So that's the basic functionality we got with the SDK at first. And so moving on from there, we decided it was time to turn up the heat and add heat in. So looking at previous work, we have to see, what have other people done in this area. And there's actually not that much, especially on the low end, which is what we're focusing on to make, obviously the average developer able to work with heat in their games. So this company called Tegway made a device called ThermoReal. You'll see that little cylinder that the person's holding can heat up or cool down, and that's using technology called thermoelectric devices. And Tegway actually made flexible thermoelectric devices so it could fit into a glove. So they actually made the glove on the top you see there where it says perception neuron underneath it. That's just saying like a sensor that shows like the position of the hand, but they also add in heat and cooling into that glove. It's not commercially available, and they don't really go into the technology behind it. And additionally, another research paper goes into using a pneumatic system, which essentially means they're pumping air throughout a glove, but they also have to have a large air pumping hot and cold air chamber set up with that. So it's not commercially viable at the moment, and also not commercially available. So that's kind of what's been done so far. And so what we decided to do is, like I said, we start out looking at the Lumia heating pad. And working from there, we got the circuit set up with Arduino. I'll be able to, if you're interested in the technical side of that, I'll be showing the circuit diagram for that. But yeah, we set up the heating pad with Arduino, and then we got it connected to Unity using the basic SDK functionality that we got with the LED, just turning the heating pad on and off. And then we started developing the SDK for the heating pad, so that involved analog control, and we had to change the method of serial communication we were using in order to be able to do that. And from there, we got it working, and we got the power control on it. So we decided to create a demo and see, how does this increase immersion? So that is the Halo demo that we set up, and I'll be showing you that in a couple slides. But it's actually pretty cool, and it increased immersion a good bit. So yeah, that's awesome. From there, we started looking at experimentation with Bluetooth. So that started out with Bluetooth low energy, which is what a lot of mobile devices use, wastes less power, but it's a lot harder to connect to through Unity than Bluetooth. And we were using a device called the Nano 33 BLE, which is like an Arduino Nano, a smaller microcontroller than the one that you see there. And so what that had on it too was a temperature sensor called the HTS221. And we wanted to make what's called a temperature control loop. So we could see, we could level out the temperature and more precisely control the temperature the heating pad is getting to. However, that sensor was pretty terrible. So instead, we decided to use regular Bluetooth and a regular Arduino Nano, and that also makes the technology a lot more accessible to the average person. So that's why we went with that. So that's kind of under temperature feedback too. And then we looked at power requirements. So how can we make this device last long term so it's not annoying? You have to recharge it like every few seconds. And there's like a lot of work that goes into thinking about power requirements. So that's also part of future work as well with this project. But the current components that we're using, so we actually decided to switch from the Lumia heating pad to the Adafruit heating pad because that you can chop that up a little bit more, and it will still work. So we could shape it to a glove or a casing for a controller. So we decided that'd be a lot better. We used the Arduino Nano. As you can see, it's a lot smaller than the original, the Arduino Uno that we're using. We used a Bluetooth module, so that's under the heating pad, and we used a transistor and a three 800 milliamp hour 4-volt batteries. Okay, and so as you can see on the right there, that's the Uno circuit, so it's a lot larger. And then switching over to the Nano, even with adding in Bluetooth, the circuit was a lot smaller. So that was awesome to see the circuit reduced like that and get to the point where it can start to be added into a glove or a casing. So I'm gonna go ahead and show you guys a demo of what the tech looks like and how it was applied to the controller and how it kind of increased the immersive experience. So let me set that up for y'all. All right, so now I'll be doing a heating function. So as you can see here, I have the Adafruit heating pad, and I'm going to wrap it around my right controller. I have 3 batteries right now hooked up to the circuit, so it should be getting pretty warm for me. And I'm going to go ahead and start. So this demo is to sort of mimic the Halo gun overheating function. So as you can see here, I have made a gun model, and I've wrapped my controller around, I've wrapped the pad around the controller, and now I'm going to go ahead and start shooting, and it gradually gets more red, and now the heating pad is heating up. And then once it gets to a certain heat, we stop the heat from going, or the current from going through the heating pad. So yeah, that's a demo of the overheating function. All right, awesome. And if you're interested in how the circuit works, I'll go over that real quick. So it's basically just a transistor switch circuit with the voltage coming out of pin 13 controlling whether or not that switch is on or off, and the analog value from 0 to 255 that you choose within the Arduino software is what can control the amount of current you're letting through that switch. All right, so now where do we see ourselves going from here? So we want to build out the heating solution into gloves or the Act1 extension. And the Act1 extension is something else our lab has done. It allows you to connect 2 controllers together, but we'll basically just use the 3D printed design of the casing because there's been a lot of work done with improving that and just adding on an extension so it can hold the batteries and the microcontroller. We also want to create a research experiment to test immersivity. So does this actually improve the user's experience? I think so. And then we're going to look at functions specific to devices. So heating control and temperature control, like I talked about. And additionally, we'll look into getting tutorials for these and ease of access. So anybody can develop with it and anybody can work with heat and virtual reality. and hopefully they'll be as happy as that guy on the right. All right, so overall, we learned today about software development kits, how to interface Arduino with Unity, how to add heat to VR and what it gave to the virtual experience, and where it's going to go from here. And yeah, that's all. I'd like to thank Jerry Hennigan, Marie Steele, Connor Borkowski, who I worked on a lot of this with, Panda, and Derek Ham from the Mixed Reality Lab, and Biomojo, the Mixed Reality Lab, and the Carolina Games Summit. So thank you. Awesome.